So this will be problem 4 and type 4 on Frobenius method. And in past we have inquired first where the initial equation roots were not differing by integer. We have inquired two cases where the initial equation roots were differing by integer, and now we will see how to solve by Frobenius method where initial equation roots actually are equal. There are no differences. Okay, so this is such an example. This is called Bessel equation of zeroth order, and I have gone through the systematic approach. First put y value, then y dash value, y double dash value, and put it in the ODE. And I have also done indexing here, which I have described in the past video. So now what I have to do is to put m equals to 0 and equate smallest x powers coefficient. That was in our working rule. So if I put m equals to 0, I get k minus 1 c naught plus k c naught, and in here we cannot put m equals to 0 because index starts from m equals to 2. So k square minus k plus k equals to 0. So k square equals to 0 and k turns out to be 0 and 0. So both the roots are equal from initial equation. Now what do we do? Now we really have to find out the recurrence relation first to decide what will be our next step. To find out recurrence relations, we equate the coefficient of our generic lowest power coefficients, lowest power of x coefficients. That means equate the coefficients of x to the power m plus k minus 1, and that becomes m plus k minus 1 cm plus m plus k cm plus cm minus 2 equals to 0. If we take cm m plus k common, then I will get m plus k and m plus k minus 1 plus 1. So that means another m plus k equals to minus cm minus 2, and cm will be equals to minus cm minus 2 over m plus k square. If you remember, the third step was to see if any of the coefficient cannot be evaluated from the recurrence relation. C1 cannot be evaluated from the recurrence relation, so we have to find out C1 analytically from this equation. For that we have to put m equals to 1, because that's how only we can find out C1. M equals to 1 gives me k plus 1 and then k plus 1 minus 1, that gives k. C1 plus k plus 1 C1, and that plus this term doesn't contribute because index starts from m equals to 2 equals to 0. So that gives C1, and if I take common, k square plus k plus 1 equals to 0. You can see for both the values of C1, this bracket term has the value simply 1 because k value is 0, and then this equals to 0, and so must C1 has to equal to 0 because this is not 0. If C1 equals to 0, C3 equals to C5 equals to C7, and all of the odd terms equals to 0 due to this recurrence relation. Now to solve, to find out two solution, we really find out our C2, C4, C6 in terms of k. Just like before, we build our y as a function of k. That will be our first task. So C2, if we want to find out C2, put m equals to 2 equals to C naught minus k plus 2 square. That will be our C2. C4 will be put m equals to 4 minus C2 over k plus 4 square, and if you put C2 value over here, then it turns out to be C naught, minus minus cancels out, k plus 2 square, k plus 4 square. Like this way, if you try to evaluate C6, it will be minus C naught over k plus 2 square, k plus 4 square, k plus 6 square. So if you try to build y as a function of k, we know what y is. Y is equals to x to the power k c naught plus c1x plus c2 x square plus c3 x cube plus c4 x to the power 4 plus c5 x to the power 5 plus c6 x to the power 6 plus go on. And x to the power k, c naught has values c1, c3, c5 is all 0. C2's value is equals to minus C naught over K plus 2 square x square plus C naught over K plus 2 square K plus 4 square x to the power 4, and then minus C naught over K plus 2 square K plus 4 square K plus 6 square x to the power 6 plus to go on. And just like before, one solution will come from this equation which describes y as a function of k if you put k equals to your root, which is 0 now, and another solution will come if you evaluate delta y by delta k, differentiate this with respect to k, and if I try to differentiate this, it will become x to the power k, and remember two parts, this part and this part. This part's differentiation will be x to the power k log x, and bracket things gets unchanged. Minus C naught x to the power 6 and k plus 2 square plus 4 square k plus 6 square, and plus go on. And if we hold this as constant and differentiate this, then really you do not have to differentiate all by yourself. Just differentiate it and put the values in the next step in the calculator. So that will be 0 minus x square C naught d by dk 1 by k plus 2 square. You don't have to evaluate it on terms of k, you just put it on the calculator. D by dk 1 plus k plus 2 square k plus 4 square, and so on. So first find out, put k equals to 0 on this solution, and you will find out that equals to C naught 1 minus x square by 2 square plus x to the power 4 by 2 square 4 square minus x to the power 6 2 square 4 square 6 square plus go on. And then you have to put k equals to 0 on this equation, delta y by delta k, and put k equals to 0, and that turns out to be if you take C naught in the common, C naught log x 1 minus x square by 2 square plus x to the power 4 2 square 4 square minus x to the power 6 2 square 4 square 6 square plus go on. And then put k equals to 0 here also, plus x to the power 0 equals to 1, and this terms equals to really x square, and all these differentiation, if you evaluate it at k equals to 0, becomes 4, and the next thing becomes x to the power 4 3 over 128. 3 over 128 comes from evaluating this differentiation. And remember, I have taken C naught out of the bracket, I have taken C naught as common, and plus to go on this. So this will be my first solution, and this will be my second solution. Remember, what will be the total solution? The total solution will be first solution plus second solution. The superimposition of your both the solutions will be total solution, and while writing total solution, you really have to make these two coefficients have look different. So just put C naught on here and just put C naught dash on the other one. So that will be your total and complete result. This is really not difficult, it is just lengthy and you have to be careful in every step. And that will be all for Frobenius method. Please don't forget to like and subscribe our channel.